So we started the recording and we're gonna start doing our class from appropriate point for today. I have a new wallpaper. Yay! Okay. So what? How much did you go forward in the last class? আমাদের আজকে কি করার কথা বলো? আমাদের কি ওয়েবজে ওয়ার্কশিট করা শেষ হয়েছে?
শুরু করছিলাম
লাইটের ওয়ার্কশিট
P2 বেশি একটা করে নিয়ে স্যার, পেপার 1 বেশি করে হয়েছিল।
কিছু শুরু করার কথা আজকে?
হ্যাঁ স্যার, না ওই দিন বেশি করা হয়নি, মানে করা হয়েছিল না, আমি জানি না, কিন্তু P1 করেছিল।
All right, so let's go for P2. আমি কিছু প্রবলেম দেখাইছিলাম শিওর। I believe এই ওয়ার্কশিটটা করা হয়েছে পুরাটা।
ও সাউন্ড শেষ স্যার, সাউন্ড শেষ।
ফার্স্ট এটাও শেষ, সাউন্ডও শেষ, লাইট শুরু করার কথা আজকে। I believe. Yeah, so we're gonna start from here. So this is the worksheet for light. So we're gonna have a lot of stuff that will be covered over here. So kids, start asking me questions that you couldn't solve or that didn't make sense. We'll go through. This question is actually not much difficult. There's a drawing that was asked over here. I mean, I'm going to show you how to draw this drawing. This is an optical fiber, so the rays coming in and the rays gonna reflect out. Did I share with you kids the video for the optical fiber? Someone is sharing your video. Stop that. Help yourself. Video share করতেছ কে?
স্যার
ইউসুফ
স্যার স্যার একটা কথা আছে স্যার।
Whoever you are sharing your video, stop that. It's blocking a whole lot of real estate in my screen. Thank you.
স্যার
বলো।
আমার 9টা থেকে একটা পরীক্ষা আছে, আমি এখন কি করি স্যার?
9টার সময় চলে যাবা?
যেতে পারবো তো স্যার?
Did I stutter?
দোয়া করেন স্যার।
Sure, no problem. কি পরীক্ষা? কোন সাবজেক্ট?
ম্যাথস, অ্যাড ম্যাথস।
Sure. So, আচ্ছা, তোমাদেরকে আমি তোমাদের মেসেঞ্জার চ্যানেলে কি আমি পাঠাইছিলাম, কি বলে রিফ্লেক্টিভ ইন্ডেক্সে কোন ভিডিও পাঠাইছিলাম?
অপটিক্যাল ফাইবার একটা পাঠিয়েছিলেন, আইসিটি
অপটিক্যাল ফাইবার দেখছো কে?
কি স্যার পাঠিয়েছিলেন?
মাত্র দেখলাম
একটা ভিডিও পাঠিয়েছিলেন।
আচ্ছা, যারা ভিডিওটা দেখো না তাদের জন্য ভিডিওটা একটু প্লে করতেছি, একবার দেখো and then I'll help you understand that thing. Yusuf, you are communicating, so don't raise your hand.
Oh, sorry sir.
It's okay.
This is only for those who don't communicate,
Who do not prefer to use or cannot use the voice channel.
Have you ever thought about how you get physical?
কি বুঝলা?
অনেক ইনফরমেশন
sir.
This was extremely detailed and it made good sense. That's why I shared this video, and that's exactly why I also made you to see that video. Yes, I'll take questions. বলো।
স্যার আমাদের যে লেভেলস অনেক কোশ্চেন আছে, কপার ওয়্যারস থেকে অপটিক্যাল ফাইবারস মানে অ্যাডভান্টেজেস চাইছে, ওগুলো কি লিখবো?
Actual question আসলে আমি আবার বলবো, no problem. There can be a lot of different advantages. If I go for one by one, let's say, compared to copper wires, optical fibers have a large bandwidth. Bandwidth in this case means rate of data transfer. Rate of data transfer. So it can transfer a large amount of data over a short amount of time because the speed of light is much bigger compared to the speed of electrons. That's one point. The other point is that copper cables, optical fibers has a much bigger data security because the signal cannot be interrupted from the external source, or it can be read from the external source, whereas copper cables can be very easily tapped from the external source because they produce an electromagnetic field around them as that current flows through them. And using an external detector, you can pretty well get that exact electrical information, and you can take out the information out of the copper cable. So the level of security is not very high in a copper cable. The other benefit is that because optical because the optical fiber essentially works with total internal reflection, which means nearly all the light, I mean, nearly not exactly all the light is reflected back to the same medium. So the loss of energy of that signal power is very small, which means you are gonna have to place repeater station. You saw the repeater station that when the amount of light actually reduces because of impurities present in the glass, we have to use a amplifier station where the weak signal gets in, gets amplified, and eventually comes out a strong signal. So using amplifier station, so because the optical fiber has a less attenuation, or it loses power at a much smaller rate compared to copper wires, you require fewer stations to transfer data through optical fiber. What I mean is that, let's say if you're trying to send, if you're trying to make a call, let's say using a copper coil from, let's say, here to Dhaka, you might require, let's say, 100 or maybe 200 amplifier. But if you use an optical fiber from, if you want to make a call using an optical fiber from here to Dhaka, you might require only 2 or 3. So you're going to require less amplifier stations for that. And there are a couple of more advantage in terms of slew rate and everything, but that is not relevant for you. So these are the 3 main advantages that you can cover. বুঝা গেছে?
Sir, copper wire lost a বেশি কেন? Because of electrical resistance.
Yes.
স্যার
Yes.
আমরা বাইরে এই যে লোয়ার রিফ্লেক্টিভ ইনডেক্সে পড়ি যে ক্লাস ইউজ করি কেন?
Because I mean, we cannot allow the optical fiber to have air around the core, but you can only have total internal reflection whenever the light is attempting to go out from a denser medium into a lighter medium. So a typical way could be that we can have a core that is surrounded by air. We could have total internal reflection. But if you're trying to place the entire thing within a tube and gonna pull this to underground, to the underground of the oceans, you cannot have vacuum or air or, I mean, gaseous medium in that structure. That's gonna make your structure flexible. So other than having air as a low refractive index medium, we use a second transparent medium which has a lower refractive index around the higher refractive index medium, which is the core. So the core has a refractive index which is bigger. The cladding is another transparent medium which has a lower refractive index. So we are basically replacing the air with another medium which has a lower refractive index compared to the core. As a result, as the light tries to go out from the core into the cladding, it cannot, because the incident angle is always bigger than the critical angle, and you have the ray bouncing in and going forward. The cladding essentially replaces the requirement of air. That's a single sentence answer. বুঝা গেছে?
Yes, sir.
Okay. So we have 3 participants who raised their hands. Okay, come up with your questions. Fardin Ahmed, go ahead. Fardin Ahmed, go ahead. Bipro, go ahead.
So can we charge a DC battery using the optical fiber cables?
We essentially can, but that would be a highly misuse of the opportunity of optical fiber. I mean, the way we can charge is that you can use, let's say you are essentially transferring light energy through the optical fibers. So other than using it for telecommunication, if you just place a photovoltaic cell or the solar cell that you have in your calculators. Yusuf, you are not talking to the channel. Please mute your channel. You are adding noise. It's appreciated. Thank you. So if you place a photovoltaic cell in front of the optical fiber and the light rays actually fall onto that photovoltaic cell, which is a solar cell, you can produce electricity out of it. The answer to your question is yes, but that would be a very degraded use for optical fiber. Something like, let's say you put Bill Gates to build up a house manually, or you use Elon Musk to make up a knife manually. That is not a proficient use of that resource.
It could have been used for other more important purposes.
Exactly. The answer to your question is yes, but it is not smart to do that. Bipro, বুঝছো?
Yes, sir. বুঝেছি.
Sure.
Sir,
Yes.
তো ওই ভিডিওটাতে সব ইনফরমেশন দেওয়া আছে না, ওখানে যে নোটস নিতে সমস্যা নেই, সব ইনফরমেশন।
হ্যাঁ, ওখানে মোটামুটি সবকিছু কভার করা আছে, ওই জন্য আমি ভিডিওটা শেয়ার করছিলাম। আই মিন দ্য কনসেপ্ট ইজ রিয়েলি ওয়েল ডিসক্রাইবড। সো এখানে আমাদের যে কোশ্চেন বলছে হচ্ছে, on figure 4.1 to continue the path of the ray until it reaches end R. So it can be drawn in two different ways. I mean, different people can have different diagrams. The reason I'm talking about two different rays is this, that if you are trying to show total internal reflection, what is really important, that you have to show incident angle equals to reflection angle. So to be able to draw that in the first place, what you need is to first draw the normal that is with the surface. Now that normal is supposed to be the radius of these two circles. So you don't have to draw this thing to such big amount, but do not draw a normal that looks like this, because this is not essentially a normal. The normal is supposed to be normal with the surface. So let's say I'm gonna draw my normal like this. This is an approximate normal. So I'm gonna first draw a normal, and then use your protractor to calculate out this angle and draw an equal angle over here. Now, once you are gonna draw an equal angle, for most cases, this light ray is gonna travel in a straight line like this. This light ray might as well reach to the other end without touching over here. But if for your figure, if it so happens that you drew this angle and your light fell over here, then you have to repeat the same process one more times. So it is possible for many of your figures for the light ray to directly come out. For some of you might have one more reflection over here and draw the same set of rating, another normal over here, and then you show that go out. Both of them are equally acceptable, because this question doesn't give you the normal, so kids can have different judgment for the normal position. That's possible. But you have to ultimately show the ray coming out of this out at this end, because the question says that until it reaches end R. So you have to draw your ray up to the R point. So you can show by one reflection over here directly coming out, or you might as well show two reflections and coming out. Both of them are equally acceptable. So, and then we have some calculation over here, so you can write this part. We just discussed this thing, and this is very simple. V equals to F lambda, so that there's no problem with that. Question number 2 says,
optical fiber information বেশি secure থাকে
because the signal which is all light signals, they are contained within the core. It is never coming out. And unlike electrical signal, which produces a magnetic field around them, light signal, as they pass through the glass medium, they do not produce anything around them that can be detected from the outside, other than cutting open the optical fiber. So you can get the information available in the optical fiber if you cut open that optical fiber without disrupting the optical fiber communication. You cannot tap it from outside, or you cannot understand, or you can even guess what is the signal that is passing through.
because these are in the forms of light.
No, because the signal is totally internally reflected. Being form is half the reason that why total internal reflection can happen, but this is possible because these are total internal reflection, which means the entire information is contained within the core. No part is going out, and light does not produce any external behavior around the cable or around the optical fiber that can be detected from the outside, which is possible for an electrical signal.
Yes, sir. আচ্ছা স্যার, high frequency light কি বেশি bright?
Not essentially. Brightness of light is essentially dependent on how much energy does that light give you.
That means if the light has high amplitude, then it is brighter, right?
Yes, you can say that. So you can have a bright red source, and you can also have a dim blue source. But blue source's frequency is higher, but red source's frequency is lower. But depending on how much energy per area or how much watt does that source give you, can determine which one is bright or which one is less bright.
Yes, sir. Understood. তাহলে the receiver has some information which has mechanisms which can detect the frequency of the light coming, right?
Usually yes. Usually yes means that in the optical fiber we can do multiplexing. Multiplexing means this is also another pretty idea, that the video that I just showed you essentially showed that one light signal was passing through an optical fiber at one point. To tell the truth, any optical fiber can simultaneously carry two waves perpendicular to each other at two different frequencies. So let's say you send one light ray that is vertical, that is polarized vertically. Now, what is polarization? I did not teach you this, but believe my words. Let's say somehow we have made a light wave that is only vertical, along the axis of the optical fiber core, and then you can send another light wave with a different frequency that is in the horizontal orientation, so that these two individual light rays can have a 90 degree across each other. Because they will be placed at 90 degree, they will not merge or they will not affect each other. They're simply going to pass to the optical fiber and eventually going out. Using two different sensors, you can distinguish the two different light rays, and you can essentially use one optical fiber for at least two simultaneous connections, which is also possible for optical fibers, but this opportunity is never available for copper wire.
That means the optical fiber can do double the work of the copper fiber if it is used smartly.
At least double the work. I would say it actually does more than double, because the speed of light is much higher than the speed of electrons. So the data transfer rate is by default higher, and also you can do double the data transfer because you can simultaneously have two channels. So it's actually largely capable to handle a huge amount of information.
Yes, sir. I see that.
Okay, so এরপর আসছে হচ্ছে কোশ্চেন নাম্বার 5. কোশ্চেন নাম্বার 5টা আপনি দেখি এখানে একটা ড্রয়িং করতে হবে, ড্রয়িংটা আমি তোমাদের বুঝাই দিব। The question reads, figure 5.1 shows a man looking at his reflection at a rectangular plane mirror. The vertical side of the mirror has length has a length h. On figure 5.1, draw a ray of light from point x that is reflected by the mirror to the man's eye. On figure 5.1, mark an angle of the incident of your ray at the mirror. Label this angle I. So from X, we have to draw an angle that will reach to his eye. Now, one thing I need to understand. The way plane mirror produces this image is that the image position is always equidistant from the mirror and behind the mirror. Now, this mirror is not essentially as long as the leg. It's not essential essential that mirror to be this much long for it to be seen on the other side. The reason is, the person can very well see the reflection of his feet when the light rays are going to reflect off over here and reach into his eye. So this mirror doesn't have to be this much long. So this mirror doesn't have to be this much long. So how can we draw this part of the diagram that is asked of us like this? First, what I'm going to do, I'm going to measure up how much is this, and from this line I'm going to draw up the possible position of the image of X. Let's say using a ruler you find this up over here. So let's say this is the position, and let's say I'm going to label this point as X prime. So you're going to measure this much to be equal to this much. So first find out the image. Once you find out the image, rest of the part is pretty simple. How do we draw the rest of the part? Just like this. From I into the point, I should use a bit thinner line, and then another ray from the X into the cross point. Now this cross point is supposed to be the behind the mirror, not the front edge of the mirror. Because the way any mirror work is that you have a thin glass sheet which has a silver coating on the behind surface, not on the front surface. So this behind surface should be do the intersection. What I mean, if I zoom in, I can show you what I mean. So this incoming light ray should cut this reflected over here, not on the front surface, rather on the back surface. This is for more accuracy point. You don't have essentially any mark for that, and I'm definitely gonna make this real line a dot 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 dot, and the light rays are travel coming out from the X reaching to the eye. So I would give relevant arrow directions, which covers this part. More part that they're asking is on figure 5.1, mark the angle of incidence of your ray at the mirror. Angle of incidence is the angle between the incident ray and the normal or drawn on the surface. So the first thing first you have to do is that you have to first draw the normal. So I'm going to try and draw a horizontal line over here to represent the normal. Okay, not okay. Fine, let's say you're going to draw a horizontal line, which is going to be the normal on the surface. So that's the idea. Okay, yes. And then you're going to label the incident angle over here and label this as I. That scores you the second mark. Then they say define the angle of incidence. You add the definition, and then it comes to this point. And B number is the important bit for you to understand. Have a look. On figure 5.1, draw a ray of light from the top of the man's head that is reflected by the mirror to his eye. So first you have to draw a ray diagram exactly identical to this one. Just it has to come from the top of the head and eventually reach to his eye. And it further says, use your ray to determine the smallest value of h that allows the man to see all of the image in the mirror from the top of his head to his toes, which means how much should be the smallest value of this h so that the person can still be able to see his image using that small length mirror. To do that, we have to draw the reflected ray from this point, Now, once again, if we are trying to draw the reflection of this point, the first thing that we're gonna do, we're gonna use a ruler and find out equal distance over here, and let's say this is supposed to be the tip of the object over here. So what we are trying to, the way we are trying to find out this position, kids, have a look. I'm gonna zoom in and try to understand. You have to understand that this ray is gonna, I mean, you have to consider from the tip of this head to the rear image over here. So let me, if I try this one, let's say. কোনদিন কাচ্চি খাই না। So you have to, I'm drawing this line just to give you an idea that what you're trying to do. So you don't have to draw this line, or you can. But what I really want to highlight is that you should definitely measure the distance from the tip of his hat to the rear side of the mirror up to here, and then from this point, this has to be exactly equal. Let's say this is supposed to be our image position for the tip of the head. They didn't ask us for any name, so I'm not going to give you any name. So this is supposed to be the image position. Once you get the image position, this horizontal line practically becomes unnecessary. So I might as well try and draw this horizontal image. If you don't want to draw this, no big deal. You can keep it. The examiner would know automatically that exactly what is happening here, which is really promising. So now what we're going to do, we found out the image position over here. Let's say the image was located over here. So pretty much like what we did over here, we're going to repeat the same process. I'm going to use purple for this purpose, let's say. So I'm going to draw one straight ray from here to the actual position, and then I'm going to draw another ray to the rear surface. Have a look. I have drawn this line up to the rear surface, not up to the front surface. Rear surface. That's the important.
The rear surface কেন দিতে হয়?
Because the silver coating of a mirror is always pasted behind the glass, not in front of the glass.
Sir, why does the silver coating matter in this?
Because a glass is basically a transparent medium. The way a glass block becomes a mirror is because of its silver coating.
Oh, it is the silver coating that makes the mirror reflective.
Exactly. Because glass is basically transparent. I might as well rub all of this part, which is my imaginary light rays, and this was not part of our equation. I actually drew this just to make sense with you. So you can draw this much, and essentially you have to give arrows. Let's say this is the incoming ray, this is the incident ray, this is the reflection ray. So you can draw this much. Now the remaining part is pretty intriguing. What I need to see that use your rays to determine that the smallest value of h that allows the man to see all of the image in the mirror from the top of his head to his toes. Have a look. To be able to see all of his image, he needs to see with his eye the top of his head and also the bottom of, which means these two are going to be our reflection points for this position. So the minimum length of the mirror has to be this much, only this much. We don't need this much big of a mirror. The minimum length of mirror required to make possible this reflection over here and this reflection over here. Now the question says that on this figure 1 centimeter represents half meter. So they've given us a scale already. So what we're gonna do, using our ruler, we're gonna measure how much is this much, and we're gonna multiply that number which we measure in centimeter with 0.5 meter. So you cannot actually essentially measure this over here because you do not have 100% figure. I also don't have. As a result, we're gonna have this scenario. Now, all that is left for you to represent that how big is the mirror length, which is this one, compared to the. No, you don't have to do anything.
Length কি 2.8 centimeter?
I'm not sure exactly how much it becomes, but if you want to calculate the exact length from the figure, you're gonna get a sample fraction of the Simin.
Yes, sir. Sorry.
It's okay, no problem. Acha. So yeah, so we are trying to calculate out how much is the height of the mirror for which the reflection is happening. So we're going to measure this out by ruler and simply multiply it by 0.5 and give the answer in actual meter measurement, not the exact value that you're going to get out of the figure. Now, interesting enough, what we can see that here you'll see that, I mean, this will essentially complete your figure over here, and you are done scoring 2 marks. Now, if I name this point, let's say this x is x prime, and let's say if I name this point h, this is going to be my h prime, right?
Yes, sir.
And if I try to copy this entire person, let's say if I try to copy this entire person, only the person, transparent selection, flip horizontal. This is gonna be his image. See if you can agree with this one. My drawing is not perfect, so it's not lining up perfectly, but the image should look like this. A bit more closer.
I understand.
Yes,
Sir, shouldn't it be a bit smaller?
You should know it's not supposed to be smaller, because plane mirrors produces images of the same size, but this is going to be a virtual image. So just to make that point, I'm going to cut this person in pieces, represent this as a virtual image. Now what I wanted to understand, that this length is essentially half of this length. Do you know how this happens? This length is going to be half of this length. I'm going to show you a proof. I want to read through that proof, and if you have any question, I'll definitely pick that up. So just let me find that proof.
Sir, in the video, there was something like that was used, like an injection on the prism that made the ray reflect. What was that thing?
They were trying to show us breakdown. They were trying to show us a breakdown. They're trying to show us that we can have the total internal reflection by either increasing the refractive index of the medium, or we can also have total internal reflection by increasing the incident angle on the inner side of the denser medium. Either of them are possible.
Sir, electrons' speed key.
They don't have a fixed speed value. There is dependent on what is the accelerating field gives them as speed.
But it cannot be it can never be bigger than the speed of light.
No, it can never be.
तो इस क्वेश्चन में हमें प्रूव करना है कि जो मिनिमम साइज ऑफ प्लेन मिरर है।
তোমরা সবাই কি হিন্দি বুঝো?
Yes, sir.
All pictures.
ছোটবেলা থেকে শুনছি।
দেখো এই ভিডিওটা দেখো।
To see full image of observer is half the size of the observer, मतलब साइज ऑब्जर्वर का जो हाइट होगा उसका हाफ होगा। तो हम ये ले लेते हैं, एक प्लेन मिरर है, ये रहा हमारा प्लेन मिरर और ये रहा हमारा ऑब्जर्वर। ये हो गया मान लीजिए हमारा लेंथ ऑफ ऑब्जर्वर। तो हम देख लेते हैं कितने मिरर का केवल हमें काम है, वही हमारा मिनिमम लेंथ होगा। तो मान लेते हैं हम कि जो ऑब्जर्वर का आंख है वो कुछ यहाँ पे होगा। तो हम देख लेते हैं कि यहां से जो एंगल इंसिडेंट करेगी, मतलब यहां से जो रे इंसिडेंट करेगी वो रिफ्लेक्ट करेगी इक्वली एंगल से। तो ये हो जाएगा हमारा परपेंडिकुलर उस जगह पे। तो हमें पता है कि एंगल ऑफ इंसिडेंस इज इक्वल टू एंगल ऑफ रिफ्लेक्शन होता है। इसके ऊपर की जो रेज होंगी वो ऊपर से जाएंगी, तो इधर देखने के लिए ये हमारी आखिरी रे होगी इस पॉइंट पे। तो ये अगर थीटा है तो ये भी थीटा ही होगा, और ये डिस्टेंस एल है। तो सिमिलर ट्रायंगल के हिसाब से ये डिस्टेंस और ये डिस्टेंस बराबर होगा। तो ये अगर x होगा तो ये भी x होगा। इसी तरह नीचे हम ले लेंगे इस ऑब्जर्वर को देखने के लिए, यहां से रेज जो जाएंगी ये आखिरी रे होगी, इसके बाद ही जो रे होगी वो इधर से पास होगी, तो ये हमारी आखिरी रे है। तो ये एंगल अगर हमारी अल्फा है तो ये भी एंगल अल्फा ही होगी, और ये डिस्टेंस जो कि सेम है मान लीजिए l, तो अगर ये y है सिमिलर ट्रायंगल के हिसाब से तो ये भी y होगा। मतलब कि जो मिरर है हमारा सिर्फ इतना डिस्टेंस मिरर का चाहिए होगा। तो ये हम कैसे निकालेंगे, ये हमारा आएगा x प्लस वाई। तो मिरर का जो लेंथ होगा वो x प्लस वाई होगा, और जो ऑब्जर्वर का लेंथ होगा वो हो जाएगा 2x प्लस 2y। तो हम यहां से देख सकते हैं जो मिरर का लेंथ है वो हाफ है ऑब्जर्वर के लेंथ का। तो यहां से ये चीज हमारा प्रूव हो गया।
कोई प्रूफ कर लो। ও
तो इस क्वेश्चन में हमें
বস বুঝছি প্রুফটা কি হবে
यहां से
দেখো
रेज जो जाएंगी
using the
ये
idea
आखिरी एंगल अल्फा ही होगी।
using the idea of congruent triangles, what he did that he proved that this triangle and these two triangles are gonna be equal because this is an right angle triangle, right? It's right
Yes,
angle,
sir.
it's right angle na. So here these two angles are right angle, so they are equal. These triangles are equal because incident ray equals to incident angle equals to reflection angle, and you have one side that is common for these two triangles, which means these two triangles are gonna be congruent. So if this is x, this is also gonna be x. See if this much makes sense. Do you guys know the four logic for two triangles to be identical to be congruent?
Yes, sir.
Yes, sir.
What are the four logics?
Yes, sir.
Side
Side angle. Sir, maths की class है।
Right angle side.
Right angle hypotenuse side.
देवाशीष सर की जिज्ञासा करो।
Anyway, I understand that you guys know this. I'm just gonna say those things just once. So if you are mistaken, you correct me. The first logic can be all the three sides are individually equal to all the three sides of the other triangle, so they are gonna be congruent. Logic one. Logic two. Two sides of a triangle and its internal angle, the inside angle of those two sides, should be equal to the same thing on the other triangle. Those two triangles are gonna be congruent. Third logic. Any two angles are equal to similar two angles on the second angle, and any of the side of the first triangle is equal to any of the side of the third similar side of the second triangle. In that case also we're going to have congruent triangles. Fourth logic is applicable for an exclusive case of two right angle triangles. If we have two right angle triangles, then if the hypotenuse of the hypotenuse and one of the side are equal, then those two triangles are also going to be equal to each other. So in this case, what we are applying the second logic, that we are applying the third logic. So we are using the concept for two angles being equal and one side being equal. So these two triangles are going to be congruous. This is this is x, and the same logic can be applied over here as well. Now have a look. This is as per the description of this person. This is the entire person's body. This is the eye level. This is the scalp level, or let's say this is a stupid English cap, not cap. This thing that the experimental question have. Let's say this is the tip of his head, tip of his toque. Do you guys know what toque is? Anyone know what a toque is?
No, sir.
No, sir.
Toque.
This is toque. Hello, this is toque. The location where Ratatouille was hiding.
Huh?
হ্যাঁ স্যার
Ratatouille.
ওই যে মুভিটা
Oh, yes.
মাউস ও ইঁদুরটা স্যার
কি স্যার ইন্দুরের মুভিটা?
হ্যাঁ, ইঁদুরের মুভিটা. So what is happening over here is that these two parts are defined as x and x. In the same way, these two parts are defined as y and y. Now, this is the part that I want to see very carefully. The entire length of the person can be defined to be 2x plus 2y, right? Entire length of the person can be 2x plus 2y, whereas the length of the mirror, the minimum length of the mirror required should be x plus y. Here is x and here is y. So I go a little bit
मान लीजिए
forward.
एंगल होगा, मतलब कि
Have a look. So the entire object was 2x plus 2y. The minimum length of the mirror is x plus y, which means the minimum length of the mirror is essentially half the length required for the whole person. So it really does not matter. It really does not matter where you stand, closer to the mirror or farther from the mirror. The minimum length of mirror that is required to see the full image of the observer will always be half the height of the observer. Another proof for this part that the position does not matter is shown in this figure. Have a look. এটা তো ছোট কেন? আচ্ছা সমস্যা নাই, ছোট হলেও হবে। এত ছোট হলে তো হবে না। আচ্ছা বড় করি। এই সকল ছবিগুলো, দরকারি ছবিগুলো এত এত লো ডেফিনিশনে থাকে, মানে মেজাজটা খারাপ করে। ওয়েল, ফ্রিতে ছবি পেয়েছি সেটা একটা ব্যাপার। আচ্ছা আমি ওই ফিগারটাতে বুঝাই, সমস্যা নেই, এটা বুঝাতে পারবো আমি। So what they're trying to show you is that if the person is over here, then his image is gonna be here. He's gonna require exactly this much section of the mirror. If the person goes further away, man standing far from the mirror, then his image is gonna be over here, and you are still gonna require that exact length of the mirror for the reflection to be seen. Which means the incident point on the mirror for any position of the object, that incident point location and the reflection point location on the mirror are always remaining same, whether the person stands close to the mirror or the person stands far away from the mirror. The only difference is close person will see their reflection closer, far person will see the reflection farther. But this length is same for both the aspect. So they have shown the rays for the close condition in green. They've shown the ray positions for the far position, the rays of the light rays for the far position with red. But irrespective of the red or green rays, this is the intersection point on the mirror. Which means whether the person stands close or far away from the mirror, the minimum length that is length of mirror that is required to see the entire image of the person is always half of the height of that person. So এই ইনফরমেশনটুকু তোমাদের এই কোশ্চেনটা সলভ করার জন্য এসেনশিয়াল ছিল না। I just wanted to cover that because this is a good point to cover that information. এই পর্যন্ত কার কোনো কোশ্চেন?
স্যার এর মানে হচ্ছে যে স্যার মানে ঠিক একই পজিশনে the incident ray will hit.
Yes.
But sir, this proof is limited to to the distance at which the observer is standing also, right? Hello?
বলো বুঝি নাই আমি কোশ্চেন বুঝি নাই, আবার বলো, সরি
স্যার এই প্রুফটা তো হচ্ছে লিমিটেড on the distance is observer is standing. যদি observer বেশি কাছে চলে যায় তাহলে তো he will not be able to see his legs and the cat.
Why?
I mean, that's what we see when we look in the mirror. Some parts of us don't get seen.
No, you can see yourself. You have to look harder. I'm not kidding. I really mean it. So, anyone else? Any other question from this one? Did it make sense altogether for everyone?
Yes, sir.
Yes, sir.
Okay, that's 2%. There are 48 additional people over here.
Yes, sir.
So what was the
Yes,
question, sir?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So number 3 is also pretty simple. I'm not gonna answer any questions for number 3. I'm gonna definitely go for the diagram for number 4, which is a bit difficult question to understand. Especially the mark scheme can set you off because the mark scheme tend to be a bit more complicated than what we are used to. So we'll have a look at this question in detail. আজকে এক জায়গায় গেছিলাম।
এই করোনার মাঝখানে স্যার
আমি করোনার মাঝখানে আর বুঝে গেছি, ব্যাংকে গেছি, এর আগে আর জায়গায় গেছিলাম, আজকে গেছিলাম হচ্ছে গাজীপুরে মৌচাক নামে একটা জায়গা আছে, দেখাই কোথায়।
দূর চলে গেছেন।
কাচ্ছিল।
আপনার মেয়ে কেমন আছে?
শেষ খবর পাওয়া পর্যন্ত
sir.
ভালো।
স্যার নাম কি রাখছেন?
নাম এখন রাখি নাই, চিটাং যা রাখবো।
কবে যাবেন আর কবে না?
আমি জানি না, গেলে তোমরা কিছু কয়েকদিন গ্যাপ পাবা।
স্যার কবে যাবেন?
Yay!
আমি পর্যাপ্ত হোমওয়ার্ক দিয়ে যাবো, টেনশন নাই।
না স্যার কবে যাবেন আবার কবে কবে?
স্যার মৌচাক কি কালিয়াকৈরে?
না, গাজীপুরে একটা মৌচাক আছে।
মানে স্যার আপনি কই গেছেন?
ঘুরতে।
এই জায়গাটুকু হচ্ছে গাজীপুর মৌচাক। আমার এটার ভিতরে কোন এক জায়গাতে
সেটা
গেছিলাম,
বুঝছি।
যেখানে আমরা ওই যে একটা সার্টেন প্রজেক্ট ভিজিট করতে গেছিলাম। আর আমি লোকেটের হচ্ছে আমি থাকি হচ্ছে কোন জায়গায়, আমি থাকি হচ্ছে এই জায়গায়।
মোহাম্মদপুরে থাকেন না আপনি?
এটা না মোহাম্মদপুর?
জাকির হোসেন রোড।
মোহাম্মদপুর কই? এখানে একটা আড়ং দেখা যাচ্ছে তো, এটা না? না, মহাখালী কাঁচা যাচ্ছে না, সরি এদিকে না, এদিকে এদিকে
রমনা পার্ক। স্যার ধানমন্ডি তো।
So this is I live in here. I mean here.
এখানে না,
এই যে মোহাম্মদপুর ওই যে স্যার।
এই যে সংসদ ভবন খেয়াল করো তাহলে হবে। ঠিক আছে, I went there.
স্যার কতক্ষণ লাগছে?
যাইতে সকালে সময় লাগছে কম, কারণ রওনা দিয়েছিলাম 6টায়, এখানে ছিলাম আমরা 2 ঘন্টা। তারপর এখান থেকে আসছি হচ্ছে এই জায়গায় দক্ষিণ খান, ওখানে ছিলাম 4 ঘন্টা। ওখান থেকে তারপর 5:30টার সময় আবার ব্যাক করছি। আজকে অনেক কাজ করছি, টু বি অনেস্ট, and it was a really long journey and I feel pretty good about this. Anyway, কি দেখার জন্য আমি ব্রাউজারে আসলাম।
মাস্ক পরছিলেন?
হ্যাঁ, মাস্ক পরছি, গ্লাস পরছি। মৌচাক না, আমি আরেকটা জিনিস দেখানোর জন্য আসছিলাম এখানে।
বাচ্চাদের নাম খুঁজতে আসছেন?
বাচ্চাদের নাম খুঁজতে আসি না। এই কোশ্চেনটা দেখাবো, এই কোশ্চেনটা বুঝাই। এই কোশ্চেন খুব ভালো করে খেয়াল করো, বলা মানে এখানে ড্রয়িং এর কিছু ক্যারিকেচার আছে, সো ড্রয়িং ক্যারিকেচার গুলো না বুঝলে কোশ্চেন সলভ করতে খুব ডিফিকাল্ট হবে। খেয়াল করো, a person standing at point A in figure 2.1 sees a reflection in a shop window of a person standing at point B. So who is seeing reflection of who? এটাকে ভালো করে ডিটেক্ট করো। Who is seeing the reflection of who?
A is seeing the reflection of B.
A is seeing the reflection of B, which means image should be produced for which object? For B or for A?
For
B.
Yes, sir.
Image should be produced for B because the person is seeing the reflection. A is seeing the reflection of B, so image should be produced for B. This is the first thing that I want you to put in your head. The first question says on figure 2.1, draw a ray of light to show how by reflection the person A sees the person at B. So this is pretty simple. To draw this image properly, we have to first draw the image of B. Now here's a catch. This is a shop window and this is not a mirror, basic shop window. So whenever there is no mirror, basic shop window, the front surface basically works as the reflection surface, not the rear surface, because there is no silvering over here. So what we're gonna do, we're gonna measure how much is the vertical distance over here, and we're gonna draw an equal distance over here, and we're gonna find out exactly what that is. So I'm gonna try to draw this with a thin line, pretty thin line. Let's say this is where the two distances are equal. Now, which two distances am I trying to make equal? I'm trying to make this distance equal to this distance. Reflection surface konta? Top window, top surface, bottom surface. Now that's the point that I'm trying to make. Okay, important. So let's say this is
Why is it that?
Because the shop window doesn't have a reflective layer like the silver. It's just a shop window where you can see a reflection of other person.
Sir, silver is quite reflective, right? As in a mirror.
it actually depends that which side of the window, shop window, has more illumination. You'll be able to see the reflection of this person using this surface as a reflector if your outside is more illuminated compared to the inside. If your inside is more illuminated compared to the outside, for example, just in the night period, then you'll see everything that is inside. The light would be coming out from here more than the light would be reflected off the surface and reaching to your eye. So your eye will essentially detect the more bright object as the more preferable object to be seen.
Yes, sir. Sir, আমি একটা প্রশ্ন জিজ্ঞেস করছিলাম যে when in a mirror silver is placed, it reflects and we see the image. When silver is in real life, we don't see any image. Why is this phenomenon like this?
Because once the silvering part is removed, you do not have a reflection surface. Light rays coming out from any part of your body or anything else will fall onto the mirror and penetrate through the mirror and eventually penetrate through the glass of the mirror and eventually be entering the air medium on the other side. If the light ray is capable to escape out in the air through the mirror and go out, why would you see a reflection? For the reflection, light rays have to fall onto the mirror, reflect off that mirror and reach to your eye. If the silvering doesn't exist, light ray can simply pass through.
Yes, sir. We choose silvering to do our reflection perfectly. But in real life, silvering এ তো আমরা আমাদের image দেখি না without the glass. Why is it like that?
বুঝি না, বলো।
Sir, we need a chunk of silver to put the silver layer in the mirror, right? We don't see our image in the chunk of silver, but in the mirror. এটা কেন?
If we polish the silver surface as smooth as a mirror, as smooth as a glass surface, we would still be able to see our image in the mirror. For example,
চামচের মধ্যে দেখা যায় মুখটা।
these are metal mirrors. They are polished metal surface. This is a metal surface, and I'm not kidding.
Sir, really?
Yes.
Oh. Metal surfaces look better than glass mirrors.
But metal surfaces are difficult to maintain compared to glass mirrors, because metal surfaces can be scratched pretty easily compared to a glass surface, because glass surfaces are usually harder compared to most metals.
But they are more brittle, right?
Yes. Okay. We'll get back.
Thank you.
You have to find out the image of the image position of the B person first. I'm gonna give a small blob over here. Although blobs are really not appreciated in CA syllabus, but since they have shown B as a blob, I'm gonna represent the image of B as a blob as well. Not a very good practice, but then again, what can I do? So fill that up, and I'm gonna label this as B prime. You don't have to label this, but I'm definitely sorry. They have said the image should be labeled as I. So I might as well label this as I. That comes in B. And then I'm going to draw the piece of ray. Now, you don't essentially have to draw this line. The A line ta aka kintu essential na. So because this line is not essentially what we are asked to draw over here, and I'm not going to show this as a solid line because solid lines can be a bit confusing. So I'm going to give a dotted line over here just to convince the examiner that I know what I'm doing. So don't confuse my ability with numbness. And then I have to essentially draw the rays that we are asked in this question. So I'm going to draw one ray. So the way we always draw the rays is from the image to the object, image to the observer first, and then you draw from the object onto the exact cross point, let's say over here. And essentially you have to give direction. Light A is in the image, so light should be coming from the B, reaching to A as I. And we have to make, because this part of the ray does not actually exist, we might as well also consider to make that broken line. So that will also work. Do I make sense?
Yes, sir.
হ্যাঁ বলো।
না স্যার পাইছি, কোশ্চেনটা পড়লাম।
ওকে,
যে আমি লাইটের কোন ডিরেকশনে ওটা কনফিউজ হয়ে গেছিলাম।
Okay, fine. So আমাদের এই দুটো হয়ে গেছে. Now we're going to go for number C. Have a look at number C. C is the part where the question becomes interesting. The person at A moves further away from B towards Y in the direction of the arrow shown in figure 2.1. So he's going to start moving along this dotted line. mark a letter with X, the furthest position along along AY to which the person can move so that the two people will still be able to see each other by the reflection of the shop window. Now here's the deal. If this person has to moves a little bit, then this reflection point will also move a little bit so that they would still be able to see each other. Now, interesting point. A bit earlier, what I just told you is that how much length do you require for seeing the whole image of the person?
Of the
Half? Half?
yes.
Yes. So this can be extrapolated with appropriate geometrical proof, which I'm not showing you. If this person moves by 1 meter over here, this reflection point on the shop window is gonna move by ½ meter. This will happen. I'm not showing you geometric proof, but it comes from the same idea that to see the full image of the person, you need to have half the length of the mirror. So the amount of movement of the person A will change the image position by half amount. So if this person is slowly moving to the right, that reflection point should also move to the right. And eventually, the last location for the reflection to be seen should be the last end of the shop window. So if whenever the light is gonna come from the B onto the very edge of the shop window and reflected onto the position of A, that is the last position where they would still be able to see each other. If A moves a little bit further down, then the reflection should happen onto the wall, which is not gonna happen, and they would not be able to see each other anymore. We are asked exactly where on this line should A be able to see the B person, or they will be able to see each other. What is the position of A for which they should be able to see each other? Now, logically, that is possible when the very last corner of the of the shop window is working as a reflection point. So we're gonna use this point as a reflection point, and I'm gonna complete the figure. Have a look what am I doing? I'm choosing purple, and let's say I'm choosing purple. I'm gonna draw one straight line from here all the way through this corner point onto this line. Check this line. Do you see the reflection point?
Yes, sir.
Very
Yes, sir.
corner of the shop window. Last border. Then again, this figure is not complete. I just drew the reflected ray, so I have to draw the incident ray as well. So I should definitely draw this one as well. And also to complete the figure, I need to give arrows and make the unreal ray vanish. So I need to make this ... So you might as well erase parts of this line, and that's good enough. And also you have to label this position as what? X. You have to label this position X. So let's just label an X over here. Now, whether this choice of your X position is correct or not, that is defined in the mark scheme in a very specific manner, which I'm going to cover in a bit. But before I go for this, let's have a look at this question. Explain how you decided the position of X. Now, explain how you decided the position of X can be explained in terms of the reflection point choice. So the way I am going to write this answer, if I was writing this, that A and B would be able to see each other as long as light ray reflects off the shop window, full stop. So we use the very last end of the shop window to draw the incident ray, and then we do the reflected ray to find out the position of the X on the line AY. So the first I'm going to mention the reason that the last point of reflection that is possible for them to see each other would be the very corner of the or end point of the shop window. We use that corner point on the shop window as the reflection point for the light ray to be coming from B back to A, or the other way around, A to B as well. Because in this question they were talking about each other, seeing each other. So that's the explanation that I'm going to write, but we're going to look at the mark scheme. এই ড্রয়িংটা বুঝা গেছে কিনা সবার?
Sir.
Yes, sir.
Sir,
বলা
আমরা যে হাফ
এটা বুঝা গেছে, কিন্তু এক্সপ্লেনেশনটা একটু রিপিট
না, এক্সপ্লেনেশন আমি রিপিট করব না, কারণ আমি একটু মার্ক স্কিম দেব, so that we can judge what the explanation is about. আব্দুল্লাহ বলো।
আমরা যে হাফ মিরর ইউজ করব, সো এটা তো আমরা সাইড ভিউ থেকে নিছি, টপ ভিউ থেকে কি হাফ মিরর ইউজ হবে?
From any position.
Okay.
আচ্ছা, so if we look at the mark scheme which is going to be available to us in this one, এটা কত নম্বর কোশ্চেন ছিল? নাম্বার 4. Lighted number 4, so I might as well use page down to move, navigate faster. So have a look at the mark scheme. Read.
Mars.
Correct position of X between second dash fourth dashed line from right of the arrow. Try to make sense of this sentence. What they are trying to mean on this figure. On this figure, this reflected ray position should be located from the second. I mean, this is the arrow. This is the first arrow. This is the second arrow. So they are saying that this endpoint should be from the second, third, fourth. এটুকুর মধ্যে কোথাও পড়তে হবে। বুঝো
স্যার আবার বুঝাবেন।
ডেসক্রিপশনটা পড়ো আগে, ডেসক্রিপশন আগে পড়ো। Correct position of X between second dash fourth dash line from right of the arrow. So arrow থেকে যদি আমরা arrow যেখানে প্রিন্ট করা আছে, আমরা যদি arrow থেকে কাউন্ট করা শুরু করি, if you start the count from arrow, after arrow this is the first dash, this is the second dash, third dash, fourth dash. So second dash এর শুরু থেকে fourth dash এর end পর্যন্ত, from the beginning of the second dash to the end point of the fourth dash, your cross point should be somewhere over here. My line touched exactly on the first point of the second dash, which means this diagram is correct. Now for an appropriately drawn figure, you should have it somewhere in the middle. The reason I'm using the term appropriately drawn figure is because if you have a look over here, for all of my drawing, I was having a huge mess because I drew a blob over here. All of my rays are not necessarily cutting in the same, but you can see that this black ray has moved a little bit to the left and so on and so forth. So in your actual figure, you are never gonna give this blob. You're gonna give a simple point. And for this point reference, you're gonna use your center. For this one, you're also gonna use the center for your reference points. So if you only draw a dot over here, not a blob, in that case, you're gonna find out that exact position, which is gonna be okay. But because the mark scheme did give us a range, so I'm still gonna score full marks for this response. বুঝা গেছে?
Yes,
জি
sir.
স্যার।
বুঝা না গেলে কোশ্চেন করো। হ্যাঁ, C2 টা দেখতো, C2 টা খেয়াল করো, C2 রিজনটা খেয়াল করো। কি বলছে? C2 তে বলছে হচ্ছে ray from B reflected correctly at right side of the window. So correctly means at the very right corner. আচ্ছা, যদি এক্সামিনেশন রিপোর্টে সি দেখাচ্ছে না, আর বি এর ভিতরে সিটা আছে অলরেডি, সো read it through. Most candidates earn at least 1 mark for the correct ray through the lens. No, sorry, this belongs to 5E. বুঝছি, এটা এক্সামিনেশন রিপোর্ট নাই, মার্ক স্কিমে শুধু আছে। So এই এক্সপ্লেনেশনটা বুঝা গেছে কিনা? Ray from B reflected correctly at right side of the window, which means you are supposed to use the very right corner of the window to show your reflection for the last viewing position. So the choice of that reflection point is mentioned over here. বুঝা গেছে?
স্যার
Yes.
এইভাবে বুঝতে স্যার অনেক কষ্ট হয় স্যার। স্যার আপনি থেকে এই অ্যানসারটা কেমনে লিখতেন স্যার? যে আমরা তো এইভাবে লিখতে পারি, মানে মাথায় আসছে না।
I would have written it like this, that as A, I mean, I am gonna write this whole thing if I was writing this answer. As A moves towards Y, the reflection point on the shop window is also gonna move to the right. The last point of reflection is the very last end on the right of the shop window. 2 sentences. বুঝা গেছে?
জি স্যার, হ্যাঁ হবে।
ওকে,
স্যার এই পার্টটা একটু আরেকবার বুঝাবেন।
কোনখান থেকে আরেকবার বুঝাবো বলো?
স্যার বুঝি না যে রাইটে মুভ করলে কি হয়।
if this person is going to move right, this reflection point is also going to move to the right, because you're going to have an isosceles triangle produced by the reflected ray and the incident ray. Here you can see one of the isosceles triangle. If the person moves to the right, for example, let's see if the person moves over here, A moves over here, let's say, in that case, the reflection would be happening from this point. Let's say, I'm going to show this with green. In that case, the reflection ray, damn it. Okay, better. In that case, the reflection ray should be this one. So your incident ray should be like this. So as this person moves to the right, this reflection point is also going to move to the right. And the last point of reflection is going to be the very edge of this shop window. বুঝছো?
জি স্যার বুঝছি।
মানে এই মানে গ্রিনটা আঁকা পর ক্লিয়ার হইছে? মানে I could draw more in between, but the whole point I'm trying to make that as A is going to slowly move to the right, this reflection point on the shop window is also going to slowly move to the right. And the last point of reflection is going to be the edge of the window over here. All right, moving on. Number 5 নিয়ে কারো কোনো কনফিউশন? আচ্ছা, এই কোশ্চেনটা তোমাদের হ্যাঁ এই কোশ্চেন আলাপ করব। এই কোশ্চেনটা একটা ভালো কোশ্চেন। কোশ্চেন পরীক্ষায় আসে, প্রমাণ গর্ব করে। কোশ্চেন দেখো। The first part of the question is pretty simple. It says the figure 3.1 shows words seen through a lens. Figure 3.2 shows the same words without the lens. So we have a we are using a convex lens, converging lens as a magnifying glass, which is actually the 6th position for application. And then state two properties of the image formed by the lens. Image is virtual and upright. You have to mention both of these properties together. And obviously the image is magnified. You can see it very well that the image is magnified because the size of the letter is more. Then the question says, on figure 3.3, sketch a ray diagram to show how the image is figure 3.1 was formed by the lens. Mark clearly the focal length of the lens and the image formed. So you're asked to complete this figure for the magnifying glass scenario. Now, before I go ahead and draw this, I'd like to take your attention to the actual position of the magnifying glass scenario. Take your book, federal book, and turn up to page number where these figures are. Someone help me.
234.
Page number 234. Yeah, turn over on page number 234. Everyone. Sorry?
একটু পেজটা রিপিট করতে পারবেন প্লিজ?
234.
234, okay.
So what you will find out in page number 234, that this is that the large table where all the individual position of the object were giving out all the individual position of the images. Now for the magnifying glass scenario, we have to cover the very lowest one where U is less than F. U is less than F means U in this case is representing the object distance and V represents the image distance. F is the focal point. U less than F means V is the object inside the principal focus on one side of the lens, which is the left side. As a result, the rays are remaining divergent as they come out of the lens. As a result, you are going to get a virtual and upright image on the object, which is the basic purpose of a magnifying glass. We want the magnifying glass to be used in this manner so that whatever we are trying to observe does not get inverted, because if your letters become inverted, it will be very difficult for you to read. So we want the same orientation, which means that you will appreciate. Munam, তোমার চ্যানেলটা মিউট করো if you're not asking questions. Thank you. So if you really want to read the letters properly, we would appreciate the letters to be in the same orientation that they are, and we would also want it to be magnified. That serves that is possible to achieve for this position where the object is placed inside the principal focus. So we are asked to draw that figure over here. Now there are multiple different steps which I'm going to explain over here, so keep your eyes peeled and your ears open. First of all, what we need to understand, the principal focus point should be outside the positions of the object, and whatever you draw up over here from this point to the optical center, let's say that I'm going to label this point. Let's say this is my optical center right over at the middle. Whatever the principal focus point that you show over here, that should be exactly equal on the other side. Now, there is a rule of thumb. The rule of thumb is that defining the principal focus first actually can give us quite a bit of trouble in terms of completing the figure. I'm gonna tell you what that problem is in a bit, but try to understand. The way I'm gonna first show you the preferable way that I opine this figure to be drawn, and then I'm gonna show you the possible implications that you might come across if you do not follow that exact procedure. The first thing that I'm gonna do is draw a straight line, long enough straight line that's gonna pass over the tip of the object through the optical center of the lens. So I need to make it a bit more up. All right, this is the
স্যার
first.
আমি ইমেজগুলো যখন ড্র করি তখন দেখেছি যে যদি স্কেল দিয়ে করি আর একটা লাইন অপটিক্যাল সেন্টার দিয়ে করি তাহলে আর এই যে অবজেক্টের টিপ দিয়ে করি টু দা প্যারালাল টু দা means the central line ইমেজটা অটোমেটিক্যালি সেভাবে আসে যেভাবে আমাদের বইয়ে ডেসক্রাইব করা হয়েছে in which case it makes it everything easier.
Good. So first you draw this line, then I would appreciate you to draw the image. So I'll tell you in a bit why am I following a different mechanism for you to draw this figure. So I'm going to draw the image over here. Let's say I'm going to draw the image right over here. So I did not define the principal focus. So I'm first choosing the image position. I have a reason for this. I'll explain this in a bit. For that, I mean, just dekhe jao. I'm not taking questions anymore. If you have questions, raise, keep your hands raised. So you're gonna label the image, and let's say I'm gonna give arrows for the image tip. And because this is a virtual image, I personally appreciate that this image would be shown as dot 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 dot. And next, you are going to validate this position. Now, what do I mean by validation? Validation means you are now, now let me give some sequence number. This is our step number 1. This is our step number 2. Now, what I need you to understand, one ray should come parallel to the principal axis, then it's gonna go through the principal focus in such a way this ray was pulled backwards. So one ray should travel from here parallel to the principal axis up to the center point of the lens. Then it's gonna refract in such a way that it's gonna pass through the principal focus point, and these two rays are supposed to be divergent. And now if we extend this ray backwards, that ray should essentially cut this ray at this point. That's how the figures are supposed to be drawn. So what I'm gonna do is draw that horizontal line. Let's say I'm gonna draw up that part with a different color, let's say purple. Up to the midpoint of the lens, and then I'm gonna continue this ray in a way that this would be my cross point. So what I'm gonna do is join up from this point. So this is my step number 3. This is gonna be my step number 3. Then I'm going to join these 2 points. Let's say that will be red. So I'm gonna join from here through this point further. Once I have completed this figure, now I will label my principal focus. This is supposed to be my principal focus. And you have drawn the principal focus over here. You have to draw it on the other side as well. So using a ruler, measure how much is this and give an equal length over here, equal length over here. Label this F as well. And so if I go for step, this was the step number 3. After the step number 3, we have to draw step number 4, which is F. and then came the labeling. But essentially you have to erase up the rays which are not supposed to exist over here, because in true case the actual rays which are going to pass through our system is this ray going undeflected, and this ray passing to the principal focus over here. These two lines are supposed to be dot dot dot, so I'm gonna make these two lines hashed. This is the appropriate way to draw this figure. One more additional thing that you can draw, but you don't have to, but you can, is you can, at the very beginning of your drawing, you can essentially try to draw the aperture line of the lens, which can help you to determine where do you need to stop. So to find out this cross point over here, you can also draw this line. This is optional. This is the way the figure can be drawn with the least number of steps with the least amount of trouble. Now, you might wonder, well, why do we have to follow this complicated new procedure? I mean, what's the deal? What if, can we not draw the figure in the actual way? Here is the thing that is the problem that you're gonna come across if you try to draw it in the exact same way that you have learned. I'm gonna show you this. So have a look. The traditional way to draw these figures is to first determine or define the principal focus point. Now you know from your experience that the principal focus in this case is gonna be further away compared to the object. So let's say you define the principal focus over here. Measure this up. You might as well draw the aperture line. So I'm going to draw that as well. Okay. And if you choose the principal focus point over here, you might as well measure this much up, and on the other side, you should give the other principal focus point over here. Now, in this case, I have first chosen my principal focus points already, and then I'm going to start to draw the figure. So here's what's going to happen. I'm going to draw one ray from the tip of the object through the through the optical center undeflected, and then I'm going to draw one row that is going to be horizontal, falling onto the lens, and we now have to draw this ray pass to the principal focus. So this is where the whole thing becomes really messy. Have a look. I'm going to complete this figure starting from here to the principal focus. These two rays are visibly divergent. Now what you are challenged with is that you have to extend these two light rays to get them a cross point in the back. Usually what happens, if you just choose your principal focus in the first place, these two light rays do become divergent, but they don't become very much divergent. Now, if I try to extend these two rays backwards, I'm going to try and do that. So see what is happening. Let's say this is going to be my extension in the backward direction. And let's say with orange, I'm going to show the diffraction over here. So now, starting from that point, it would not help. I need to extend this line, so I might as well start from a random position. This is where your image is supposed to be. In many cases, this point will fall outside the boundary of your page. Check this out. To complete this figure, what you need to do, is this. You have to first extend out this line, horizontal line. And then you have to draw another vertical line from this point onto the principal axis. And then you have to give arrows to make sense. Obviously, the ray figure arrows are missing here, which you should give and must give. So here comes the arrows, 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 arrows. And you have to erase up these parts because these light rays are actually not messing around. So that's another thing. So the problem that happens whenever we go for traditional mechanism to draw, this object can fall really far away because the two light rays might not be really divergent. Have a look what I have done over here. I chose the image position first. As a result, the rays have become enough divergent. I could still conveniently label F, and my figure is very well contained on the left side within the boundary of the page. What I do recommend that for those of you who still haven't attempted the worksheet, try to choose a value of f as your own and try to complete the figure, see what you get, and see if you are happy with that. If you are happy with that, you don't have to follow this procedure that I just showed you. This is just show off. বুঝা গেছে? বলবান কেন আমি ডিফারেন্ট মেকানিজমটা দেখাইছি, এটা কি বুঝা গেছে সবার? What's the problem that I'm trying to circumvent?
Yes, sir.
Yes, sir.
Okay. Yes, Abdullah bin Jalal.
স্যার আমি যদি এফটাকে আরো দূরে নিই তাহলে হয়ে যাবে না, মানে যতটুকু স্পেস আছে তার মধ্যে ইমেজটা চলে আসবে না?
That's the point. তুমি যদি এই ফিগারটা বাসায় enough practice করে থাকো, then from your experience you would know that unless I place the f really far apart, these two letters are not going to be enough divergent to give me a cross point available within my range of page. You would only know the f is supposed to be really far away provided you have done enough practice and you know this problem, that this problem can come.
Yes, sir.
To avoid that process, I'm starting from the image process. So that's why I define the image tip first and then use that thing to define all the other stuffs over here. So I used a little bit of reverse engineering to get a really big, really good looking figure. That's what I did.
Yes, sir, understood.
So is it clear to everyone that why am I trying to convince you about this? আপনার হাত দিনের নামের শেষে বিলিয়ন্স লেখা কেন? Okay, Aptai, that's pretty cool actually. Billions and billions and billions and vegans and beans and vegans and beans and vegans and beans. I also got a copyright claim for that part. I had to cut that out from my video because if a certain YouTube channel gets 3 copyright strikes, that video channel gets banned. So I had the copyright claim. I immediately cut, trimmed out those parts. And আজকে ক্লাস 9 এর ক্লাসে আমি পোলামানদেরকে পড়াইছি ওই যে বায়ান্সি ফোর্স। সো ওটা বোঝানোর জন্য মার্ক রোবার একটা ভিডিও আছে, ওটা আমি পোলামানদেরকে দেখাইছি। এন্ড মার্ক রোবার চ্যানেল থেকে কিছু দেখালো, মানে ভালো হাই লেভেল ইউটিউবার যারা আছে ওদের ভিডিও থেকে কোনো চ্যানেল আমাদের ভিডিও থাকলে একটু পরে দেখা যায় কপিরাইট ক্লেম করে বসে। সো ইউটিউবার এটা কপিরাইট ক্লেম দিবে, দেখেন আমার ওই পার্টটুকু আবার ট্রিম আউট করা লাগবে। কি যে একটা বেজাল। আচ্ছা যাই হোক, we're going to move on to the next question and let's have a look. এটা ঠিক মতো আঁকবা এবং আচ্ছা এটা কেমনে আঁকবা আমি আঁকার প্রসেস দেখাচ্ছি। বললাম আমি এখানে যে সবগুলো রিলেভেন্ট ফিগারের ড্রয়িং গুলো তোমাদেরকে দেখাই দিচ্ছি। দে আর ইন দ্য ভেরি মানে কি রিজন ইজ দ্যাট সো দ্যাট ইউ আর নট মিস্টেকেন ইন ইউর ড্রয়িংস। ইটস রিয়েলি ইম্পর্টেন্ট দ্যাট ইউ ডু নট মেস দিস থিংস আপ বিকজ লাইটের কোশ্চেনে তোমার যদি কনসেপ্ট ক্লিয়ার থাকে খুব ইজিলি অল্প ড্রয়িং করে তুমি অনেক মাস ক্যারি করে ফেলতে পারবা। আই মিন দিস আর অ্যাজ গুড অফ প্রবলেম লাইক ইলেকট্রিসিটি or kinematics, not like thermal, not like magnetism. You can score really good number marks in a very short time if you have your basics correct and if you are careful for the quality of your drawing. Now many of you might think like that's a lot of ifs, I cannot cover all those. It's up to you. Did you guys know that if you have to explain a sarcasm, it becomes really, 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 really morbid?
Yes, sir.
Only Abdullah know this?
স্যার আমরাও বুঝি স্যার।
লাস্ট কোশ্চেন একটু যেতে পারবেন?
Last question ছিল যে do you understand if I have to explain sarcasm, it becomes really, really, really morbid? That was the last question. Did you mean what? আচ্ছা আমি কি বলে এই যে ফারদিন তোমার একটা ভিডিও দেখলাম that you made about some training program which and did your hair really grow that long?
Yes, sir.
My God. And you did not cut during the entire COVID started? You look hot.
স্যার লাস্ট কোশ্চেনটা একটু নিয়ে যান প্লিজ।
হ্যাঁ বলো।
স্যার ওইখানে আপনি আগেই ইমেজটা বানাই দিলেন তাই না?
হ্যাঁ
তো স্যার ওইটা যে আপনার মানে যে হরিজন্টাল লাইন অবজেক্ট থেকে লেন্স পোর্শন ওইটা দিয়েই যে যাবে এটা আপনি
এটা দিয়ে
আচ্ছা
না,
স্যার আমি ভিডিও
এটা
দেখে নিব না পরে
না, আমি তোমার বলতেছি, I totally get your question. I'm answering your question. You'll get your answer even if you didn't answer the question completely. What I don't want is the cross point of those two rays to fall outside the margin of my paper.
Yes.
If you need, you can extend this line on the left side, you can extend this line on the right side as long as your page allows it. But you cannot write anything on the right side where there is a margin, it says for examiner's use. You cannot write anything over there. But you can extend this line backwards. But you do not have a messed up situation where that cross point goes far out than the margin of your page. If these two light rays which are coming out are not divergent enough, then they're going to meet at a really far away back point. That's what I'm trying to avoid in the first place.
Okay.
বুঝতে পারছি?
Yes sir, thank you.
Did I answer your question?
Yes sir.
Good. So let's have a look for this question. The question, let's have a read for the question. The next one. Figure 6.1 shows a ray of white light, a white light from a ray box passing into a glass prism. A spectrum is performed between P and Q on the screen. So you have these things, state the color of the light and P of the screen. আচ্ছা এই কোশ্চেনটা আমরা যেভাবে সলভ করব সেটা হচ্ছে এরকম. First you draw the rays. I mean, you don't have to draw 7 different rays. Many kids draw 7 different rays. Don't do that. I mean, draw one ray like this and then complete this ray up to here, and then complete another ray slightly thin, and then over here. In this case, both of your rays are essentially bending in the same direction. They are both bending away from the normal and close to the normal as they are supposed to be. You can.
I have a question.
You can only draw this much. You don't have to draw
Sir.
you don't have to draw 7 different rays. Yes.
Sir, is the wavelength proportional to the bending?
বলো.
Sir, is the wavelength proportional to the bending?
Sir, inversely proportional হয় না, less wavelength more bending.
I am not gonna say it's a I'm not gonna use the word proportional because the word proportional is a very I'm gonna use this word. It's a very sacred mathematical relationship. Whenever you define two variables to be proportional, it essentially by default means directly proportional. Directly proportional means if you plot those two variables, you're gonna get a straight line that passes through the origin. So I'm not gonna say that it's directly proportional, but what I can say that as wavelengths get bigger, deflection becomes smaller. So I'm not going to use the word inversely proportional or directly proportional. I mean, you can see what I have shown you in the earlier case that red bends less and the violet bends more. So here, this would be the red end, this would be the violet end. So violet has a wavelength that is less than the red. So I'm going to say that for bigger wavelengths, bending is less. That's what I can say. But I'm not going to go ahead and use the word directly proportional or inversely proportional because that might be a bit of a far-fetched idea. বুঝতে গেছে?
Yes, sir.
এটা পারবা আমি এই ফিগারটা দেখাই. Figure 6.2 shows the ray passing through a red filter before it passes the prism. Complete figure 6.2 show the ray of the red light passing through the image. So red light কাটতে হলে আমাদের just P point বন্ধ রাখতে হবে. You don't have to draw anything up to Q because we are filtering out all the other wavelengths, only allowing red. So you're going to have a single line over here going from here to here. Let's say I'm going to draw this with red. Why not? Because I can.
So red filterটা কি করে?
It absorbs up all the other colors and only allows red to pass through.
Sir, what happens to the lights of the color of the lights are?
They are absorbing the material which produces heating effect, and that heat energy gets immediately dissipated to the surrounding.
Sir, আবার বলবেন কেটে এসেছে.
that absorb heat light energy, converts into heat energy into the filter. That heat energy gets dissipated to the surrounding immediately.
Yes, sir. Understood. Thank
Sure. And of course, for all light figures, you have to give arrows. Don't forget your arrows. It's very important. এই ফিগারের ড্রয়িংটা সব বুঝে গেছে?
Yes, sir.
Yes, sir.
আচ্ছা, এখানে বলছে
স্যার ক্লাস কয়টা বন্ধ হবে?
ক্লাস অ্যাকচুয়ালি আমি ছেড়ে দিতে পারি if you want.
জি স্যার।
তোমরা এই সবগুলা অ্যাটেম্প করবা। আচ্ছা, I have one more thing to declare. সেটা হচ্ছে upcoming week in one of the classes I'm going to ask you to snap pictures of all of your P1 and P2 worksheets in the P2 worksheets working that you have done to solve those worksheets. I mean, they might be, I mean, if you have printed out the worksheets in your home printers and you have solved them on the paper, I would ask you to take pictures of all of those worksheets and send me in my messenger window personally, not in our group messenger thread. Or if you have solved them in your copy by looking at the questions in the software form, in the soft form, I would like you to take picture of that working and send all of those things to me. I want to check how many of you are actually relevant to your homeworks. When you're doing all the classes, your lectures are provided in YouTube as backup. Maybe what I feel is, actually what I was notified about, that some of you are slacking off in doing your worksheets. You are very much allowed to study other subjects, but that would not allow you to be less careful about other subjects as well. So sometime in our upcoming week, I'm going to ask for those documents. So I just declared it. I'm not saying that when I'm going to demand that. And there'll be a stipulated time frame within which I would like to have those things received. Unless I receive those, I'm going to talk to your parents, which I don't want to do, but I'm going to do it anyway. Could I pass the information properly?
Yes, sir.
বুঝা গেছে কি বলছি?
Yes, sir.
I need to have evidence of your homework, period. Okay, I'm gonna close the class for today. I would like all of you to attempt the remaining questions as much as you can. At least if you find some drawing that is difficult, that you cannot make sense of, try the ones that which does make sense to you. And everything that you have questions, make a list of them so that we can actually do the rest of the worksheet in a selective manner from next class. Thank you, kids. Good night.
Sir, আমার একটা প্রশ্ন ছিল।
বলো।
স্যার, আপনি কোন ওয়ার্কশিট থেকে